Hello, everybody, and welcome to today's presentation, NoSQL versus NewSQL, Evaluating Database Technologies for 2019, brought to you by VoltDB. I would like to introduce you to our presenter, Chai Bhatt. Chai is the Director of Product for VoltDB. Chai has over a decade of experience in product strategy and databases, and prior to VoltDB, he worked at notable organizations like Akamai, HPE Vertica, Intuit, and Aspen Technology. So, and with that, I'm going to start our first poll question. Our first question is, which of the following database technologies are you evaluating or considering in 2019? Great. And here are the results for our first polling question.
Thank you, Billy. I appreciate that.
Awesome. And with that, I'm going to turn things over to you, Chai, to begin the presentation.
Thanks, Billy. Hello, everyone, and welcome to today's webinar on NoSQL versus NoSQL and evaluating database technologies for 2019. As Billy mentioned, I'm Chai Bhatt, and I'll be your presenter today. If you have any questions, feel free to post them as we go along, and we'll get to them in the end. But without further ado, let's get started. So here's the agenda. We'll start with talking about the database landscape. Then we'll current database landscape. We'll get into the birth of NoSQL, why NoSQL was formed. Then I'll give a short introduction to SQL. Then we'll get into NewSQL. What exactly is NewSQL, right? That's a relatively new term, so I'll explain what that is. Then we'll get into VoltDB, which is just a version of NewSQL. Get into some of the use cases of NewSQL, and then provide a summary at the end, and then we'll do the questions and answers. So before we begin, essentially there's three ways to interact with any database. The first is through a JDBC or a ODBC driver, and that essentially lets you make query a database with SQL statements without actually getting into the database through an API. So it's very popular with application developers out there because you can work through an API. You don't actually have to get to one specific database. You can query many databases, and you can query them with JDBC or ODBC. However, when it comes to scale, this doesn't really work too well, because if you have a lot of transactions coming in at a high volume and a high velocity, querying them through JDBC or ODBC is not the best approach. And there's a lot of problems associated with this, because every time you make a query, the database is looking for permissions, it's looking to lock certain records and give permissions to certain records, and so on, if the request is coming through externally. So it slows down significantly. So that typically it's not a good approach unless you want to do some kind of ad hoc querying or something like that. If you want to do a lot of querying on a lot of data, which is coming in at high velocity, definitely this is not the way to go. The other approach is the NoSQL approach, and there's a bunch of different NoSQL databases out there, and I'm kind of lumping them into one general category for the purposes of this webinar. So what, in general, NoSQL databases do is they take the transactions, all the transactions that are coming in, and they move them over to the client side to do the analysis on. So it's a very developer-friendly way of doing analysis. It's very popular with developers. However, the problem is if you have a lot of transactions coming in, I would say millions or thousands of transactions coming in, every time they come in, you have to move them to the client's side, and you're kind of tying up your network that way. You're doing a lot of back and forth, so there's a lot of network traffic, and there's a lot of latency, unnecessarily latency that's introduced in the process, because the data has to go back to the client and back again. And then the third way is through stored procedures. So stored procedures, I like to think of them as SQL shortcuts. So essentially, it's a bunch of SQL statements that are on the server side and that execute well when you make a query. So SQL statements are very powerful, and stored procedures are very powerful. They run really, really fast, and since they're kind of pre-compiled, you get query responses at blazing fast speeds. And they're very predictable speeds. You can use them repeatedly. So if you have queries that you run a lot, or if you have any complex queries that you run often, stored procedures is the way to go. They're not as popular with developers just because you have to kind of write them up front. So there's a little bit of upfront work required with stored procedures. But once you write them, it becomes easy. So those are kind of basically the three ways to interact with the database. So before we get into NoSQL and NewSQL, let's look at why those technologies were formed and why they came into being. So that involves looking at essentially traditional database management systems. So, they've been around, companies like Oracle, DB2, Sybase, MySQL, SQL Server. They've been around for a long time, 70s, 80s, and so, they've been proven for decades, right? They're very, very compatible with other tools and, your typical enterprise ecosystem. You have CRM, ERP, supply chain tools. They work very well with those because they've been so around for so long, they have native connectivity to all those tools. They offer really rich client-side transactions, very good ad hoc query and reporting, so you can, point BI tools at these databases and generate historical reports. And they're very standardized since they've been around for so long. Again, they work, and they have a very good ecosystem in place already. They work with ETL tools, BI tools, and so on. So that's the positives. The problem is that when big data came into being about 10, 15 years ago, a lot of data started coming in at a very high volume of high velocity and variety. And these databases were just not architected to handle the capacity of big data. So they started crumbling because of the high volume and velocity of the data that was coming in. And they just could not scale at all. So, and they could not handle the scale that came with big data. These are almost always mostly disk-based systems. Architecturally, at least the inherent architecture was disk-based. And traditionally, disk-based querying is slow compared to especially in-memory systems. Most NewSQL systems, which I'll talk about soon, are in-memory systems. And memory has gotten a lot cheaper over the years, and now it makes sense almost to run your queries in memory nowadays. And these systems are disk-based, so they're inherently very slow. They're very poor performance, especially for modern web-scale apps, right? So really modern web-scale apps, when you're looking at the high-velocity data, high volume of data, and a variety of data, it's not just your traditional structured data anymore. You have unstructured data, you have semi-structured data. They're just not built to handle that kind of data. And there's complex tuning required for these databases. So, they've been around for a while, and, almost each flavor of the database has their own experts. So, you have an Oracle DBA or a SQL Server DBA or a Teradata DBA or an IBM DBA, and they've worked for years and years on that specific database, and they know the nuances of the general purpose database, and they can fine tune it. And you almost require those DBAs for that specific database, and they're hard to come by. And, they've kind of employed the one-size-fits-all approach because they've been around for so long. When they were first architected in the 80s, you had just so much data coming in every month. It was very predictable, and, it was nice and structured data. It fit nicely in rows and columns, and you could do queries on it. Things have changed since, right? And there's no longer a one-size-fits-all approach to that's kind of why general-purpose databases are just not right for all of the multitude of use cases that are out there. So here's kind of a database landscape as it exists right now. And this just goes to show, this was put out by 451 Research a couple of years ago. So since then, they've probably added even more databases to this landscape. There's literally hundreds of databases, right? There's non-relational databases, the relational databases, there's graph databases, grid cache databases. And, it's all in this maze of databases. You really need to find the right tool to do the right job. And that's the hardest part. So why was NoSQL formed? As I mentioned, traditional databases just could not scale. They did not have the performance. that's necessary for modern web scale applications. So NoSQL was kind of born to answer those problems that traditional databases had. And what initially NoSQL databases decided was that, hey, SQL is bad. They kind of associated SQL with the architecture of these old legacy databases, and they said, let's move away as far away from SQL as possible. So they decided to call themselves NoSQL. They did not use SQL as their query language, and they completely re-architected themselves, the architecture to be more scalable and more performant. So there's a bunch of NoSQL databases out there, right? There's different varieties. There's the key value databases, there's the white column stores, there's a document store, there's an extensible databases, and then there's graph databases as well. So like I said earlier, in this webinar, we'll kind of look at them in general rather than dwell into each category of NoSQL databases. But in general, they all are NoSQL. They don't use SQL. At least they started out not using SQL. So here's some of the benefits of NoSQL databases, right? They're very flexible. They're kind of built for the big data problem, the high volume, the variety, and the velocity of big data that came about 10, 15 years ago. They offer the flexibility and the scale that traditional databases do not offer. So if you have if you have data that comes in and it changes often, NoSQL databases are the way to go, and they handle large data sets really well. The problem is they always sacrifice consistency for high availability. So if you look at the CAP theorem, right, it talks of the CAP theorem is almost three edges where you have availability, partition tolerance, and consistency. And NoSQL databases, they're highly available. So every time you make a query to a NoSQL database, you're almost guaranteed to get a response. There's no guarantee that the response will be accurate, and it will be the most recent data that you'll be getting in the response to your query, but you will get a response. So that's their guarantee. And they're really good for non-relational, unstructured data or semi-structured data. So they were, while traditional databases were kind of only good for structured data, NoSQL databases are very good to handle any kind of text analytics or any kind of JSON unstructured data, delimited data that you may have. It fits really well in NoSQL databases, and you can query it really easily. And their performance is much better than traditional databases out there. And here's the thing that they're very popular with developers, and as you guys pointed out in the survey earlier, you're looking at NoSQL databases because you really, it's easy to get started with them. You don't need to build a schema, define a data definition layer to kind of get started with your querying the data. You can just take the data, put it in, and then query it. You don't need a schema up front. However, as I mentioned earlier, NoSQL databases kind of were born and they distanced themselves from SQL. But over the last 2 or 3 years, there's been a change. So, you look at some of the traditional NoSQL database companies out there, like Cassandra or MongoDB, and what they've decided is that SQL is still essentially the best way to query large data sets. And it's the most efficient and the most flexible and the easiest way to run queries on large data sets. So now they have kind of transformed themselves, NoSQL databases, and they call themselves as not just SQL, right? So they have introduced SQL-like query languages. For example, MongoDB has Mongo query language, Cassandra has Cassandra query language. So they're not SQL, but they're SQL-like. So it's kind of like a things have come back to SQL, and there's a good reason for that, right? Because SQL is still, it's been around for a while. It's been an ANSI standard since 1986. It's very standardized, unlike the NoSQL databases that are out there. There's a lot of fragmentation. There's no standardization. So if you have a developer and in your company and he gets you started with a NoSQL database, and then if he leaves the company for some reason, it is really hard for the next person to take that job, who takes that job, to kind of continue where they left off, because there is no standardization. It's basically a lot of the knowledge is lost when this developer goes out the door. SQL, it's not like that. You have a SQL database, it's standardized. Whoever comes in can run queries on it. They can learn this, they have the schema, they can modify the schema, they can adjust the schema and continue to function as well. So that's a huge plus for SQL. And interestingly, SQL still has never been out of fashion. I just looked that up a couple of days ago. I was just curious, and the most popular programming language out there is Java right now. And SQL actually has 30,000 more job openings than Java. So it's extremely popular, and it's kind of coming back in style, even with the NoSQL vendors. So, and the other thing is there's already tons of existing applications and platforms that are out there that are currently leverage SQL, and it's easy to connect to them and exchange information and get information from these platforms because they already speak SQL. And here's some of the benefits. As I mentioned, SQL it's standard. It's been out there for a while. It's declarative, right? So when you're running the query on a SQL database, all you need to ask is what you need in your response. And then the database takes care of everything behind the scenes. So if there's tables that need to be joined, if the data that needs to be moved, the database does all that for you. You just simply write a declarative query and you get the response that you want, versus having like a imperative database where you have to specify exactly what you need, what to do, what to get from, and stuff like that. You just don't have to do it. It's very simple. And it is extremely scalable. And when I say scalable, I'm talking about NewSQL. NewSQL makes SQL scalable. So what NewSQL did is it actually got rid of all the architecture deficiencies that traditional databases had, but kept the good part, the SQL part, and it made SQL much more scalable. And I'll talk about that soon and give some examples on that. And, it's extremely flexible as well. So, traditionally SQL, there's a perception out there that, hey, SQL is very good for structured data. That's just not true. It's very, very flexible and extensible. You can query unstructured data with it. You can, if you have a clickstream coming from your website, JSON data or delimited data, you can query it together with your structured data using SQL. And you can even query unstructured data using SQL. So it's extremely extensible. Upserts, for example, I think ANSI 2003 added upserts to their capabilities as well. So it's all continually evolving, and it is a lot like ANSI 2003 and ANSI 2008 have made SQL far more extensible and flexible than it ever was before. And mostly it's proven and it just works, right? So here's kind of like the maturity wave for operational databases. As I mentioned earlier, legacy databases, SQL-based databases were formed in the 70s. They were very stable, secure, accurate. However, they did not scale, and that's why NoSQL was kind of born in 2012. Its kind of aim was to solve all the problems that legacy databases had. So it was fast, it was scalable, it was fault tolerant, it was decentralized. But it did not provide consistency. It did not provide the scale that some modern apps need. Although it was scalable for apps that were 10, 15 years ago, it does not provide the scale for modern web scale apps. It did not provide consistency. And then Hadoop came along, and Hadoop was another open source project. It was supposed to be low cost. It had multiple integration, but there was just too much fragmentation in the Hadoop industry as well. There was never any standardization, so Hadoop really never took off. Although a lot of enterprises still use Hadoop, when they're referring to Hadoop, they're referring to the Hadoop distributed file system. They still use that layer as a place to store data for cheap, but it's really, really hard to access the data that's stored in Hadoop. And it's kind of evidenced by recent industry events where Cloudera and Hortonworks have merged, and so there's a lot of turmoil going on in the Hadoop industry as well. So the latest evolution of databases is NewSQL, right? So NewSQL, essentially you get the best of both worlds. You get the reliability, the flexibility, and the proven use that SQL has always provided, along with the scalability, the low latency, and very strict asset compliance, and a much, much lower total cost of ownership than your legacy systems and your NoSQL systems. So VoltDB is actually a NewSQL database. So VoltDB was formed almost 10 years ago by Dr. Michael Stonebreaker, who won the Turing Award, AM Turing Award a couple of years ago. And he formed VoltDB. He kind of started from a blank slate of paper, and he decided what were the modern requirements of a modern database, and based on those requirements, he architected VoltDB. So VoltDB kind of gives you, the scale that modern web-based web scale apps need. It gives you really, really fast millisecond responses. It gives you the availability you need, but it also guarantees really, really strong ACID semantics all across. So you don't really have to compromise on ACID. You don't have to compromise on consistency. You don't have to compromise on durability, but you get the scale and you get the millisecond responses that you need. So that's kind of the favor of NewSQL that we'll be talking about. So when do you use NewSQL, right? So you want to use NewSQL. I mean, again, it's the right tool for the right job. I'm not saying that NewSQL is the one silver bullet that solves all your problems. Here's when you'll use NewSQL. If you have apps that require really, really high throughput, or if you think an app is going to go wildly popular and you're going to need the high throughput in the future, you need to use a NewSQL database. Basically, if you need really, really low latency in your applications as well, and I'm talking about milliseconds, right? NewSQL is perfect for that. And then there's, traditional databases, they're really either very good at transactional processing, or they're good at analytical processing, and you have to go with one or the other. You have to pick one or the other. NewSQL databases are what we call hybrid transactional analytical processing databases, HTAP, so they do both. They're really, really good transactional processing, and they do analytical processing as well. And it gives you the best, it's the exact same SQL as all the databases out there use. So it's ANSI compliant SQL, ANSI 2003 compliant SQL that everyone else uses. SQL obviously has rich functionality that's been proven, and it provides in-depth analytics. So if you need materialized views, you have those. If you want to employ stored procedures or user-defined functions in your database, you have the option to do that as well. So you can do really rich analytics within your transactions with NoSQL databases. And if you have some apps which require you to get started easily and use key value functionality, NewSQL actually offers you that flexibility as well. You can use key value functionality with your apps with NewSQL as well. And best of all, I would say that almost every modern app out there should be using and utilizing machine learning. And when I'm talking about machine learning, I'm talking specifically about operationalizing machine learning. So you probably have data scientists on the staff, and they're using your historical data and the new data to build machine learning models. And usually what I've seen in my experience is that these machine learning models are almost always implemented on analyzing historical data, kind of seeing, it's almost like looking in the rear view mirror, what happened in the past and what we could have done better, rather than using these machine learning models to actually improve your current present day operations. So what NewSQL databases do, they can actually deploy the machine learning model that the data scientist has built within the database, embedded in the database as a stored procedure, so that when new data is streaming in, you can actually run the model in real time and take actionable decisions based on that model. And then as new data comes in, you can actually use that data to train the model as well and update the model as necessary. So that's a capability that comes built in with NewSQL databases. In that, unfortunately, I haven't seen many NoSQL or legacy databases that let you operationalize machine learning as smoothly. So we talked about NoSQL databases, we talked about SQL databases and NewSQL databases, and we talked about big data, which kind of came into being, I think, 10 years ago. But since the advent of big data, things are changing as we speak. And so here's some of the market disruptors for 2018 and 2019. A lot of you may have heard 5G is being deployed across the globe. I read an article last week which says that AT&T and Verizon have started deploying 5G in select cities across the U.S. And I think within a year or so, 5G will become a reality. And 5G is really a game changer. So, we all use our phones on 4G right now. 5G is exponentially faster than 4G, with speeds that are about 100 times faster than 4G. And what 5G is going to do is it's going to actually enable a lot more devices to be connected than 4G did. So you're talking about millions of devices per square mile. So all the density of devices and the speed that 5G is going to power is really going to make IoT and the Internet of Things, machine-to-machine sensor data a reality. Because that's what was kind of missing to make IoT a reality, was the speed. And 5G is really going to bring that. And with the speed and the volume of data that's going to be created by 5G, and the velocity of the data that's going to be streamed in from 5G networks is going to be much faster and much bigger than anything we've ever seen before. So it's almost like you cannot analyze the data. You can't take the data and store it in your data warehouse or on Hadoop and analyze it. You almost have to analyze it instantly just because it's streaming in so fast. And that kind of applies to machine learning as well. So you're going to almost have to analyze the data and apply machine learning to it as it streams in. And then cloud, cloud's kind of become a reality, not just the public cloud, AWS is surging, but also the hybrid cloud, right? I mean, so it's critical for modern day apps, not just to be able to be deployed on premises, but also be deployed in the cloud. A lot of web-based apps, modern apps are deployed to a containerized environment like Kubernetes. So the NewSQL databases enable you to actually deploy a database in your containerized Kubernetes environment as well. So all these market disruptors are becoming a reality in 2018 and 2019. Having said that, here's some of the common use cases for NewSQL databases, right? When VoltDB was formed, I think close to a decade ago, historically we've been very, very strong in the telco industry. Because telco always has been one of the strictest industries out there when it comes to requirements. So their latency requirements, their performance requirements, and their scalability requirements have always been extremely rigorous. And with 5G coming on the horizon, they've actually become even more rigorous than ever before. And VoltDB has kind of proven itself in the telco environments for years now, and hence we have, as I would say, a lot of our use cases are in telco. We have a lot of the telco apps that do billing and run their operations, that do fraud detection in real time on stolen phones and so on. They're all powered by NewSQL VoltDB. But the use cases are not clearly limited to telco. We also have, wherever you need, if you have a lot of data streaming in really, really fast and you need to make decisions on it instantly, NewSQL is a really, really good choice. So if you have, you're doing any kind of trade risk analytics, if you're doing any kind of fraud detection on financial data, NewSQL plays a very good role as well. Again, when you have, the same goes for personalization for e-commerce, targeting ads and making them very specific to the person who's seeing the ads, which require really split milliseconds of response times. NewSQL is perfectly suited for that. In IoT, there's millions and millions of, there's tons of data streaming in from sensors and meters, and it comes in really, really fast. So NewSQL is very, very ideal for that scenario as well. So that's kind of, anytime you have data coming in at a high volume and a high velocity, and you need to take decisions on the data as soon as possible, is where NewSQL is kind of ideally suited for. So let me dig deeper and go into some of the use cases of NewSQL, and this is some of our customers and how they use them. I wish this particular anti-fraud platform that Huawei has deployed in Asia was around 10 years ago, because 10 years ago I was traveling and I was at a hotel, and I happened to use my credit card on an unsecure Wi-Fi network, and I did not know that right away, unfortunately, but it was hacked. And a couple of days later, the credit card company called me, and they told me that my credit card, while I was in the Boston area, was used in New Jersey and New York for the last 2 days, and they've racked up charges for about $2,000 on it in 2 days. So it was too late, all right? So the services, the products were already rendered. The vendors had already provided the services to the fraudsters, and someone lost money. So the credit card company lost money, the vendors lost money. It was too late to do anything. So this real-time fraud detection was just not available 10 days ago, because the database technology back then was just not good enough. Fortunately, now it is. And, Huawei has embedded VoltDB in their technology so that as new data is streaming in, they have a machine learning model built into the database, which can look at hundreds of events and make decisions in milliseconds and detect fraud. So if it's a fraudulent transaction, they can actually block the transaction in event and prevent the transaction from getting through and block the credit card before the transaction happens. So that saves a lot of money to banks and to vendors, and everyone's happy, right? So, but it's not just fraud detection. They actually also use embedded machine learning to detect stolen credit cards. They use it to detect accounts that are hacked, distributed denial of service attacks they prevent from embedded machine learning, and they actually also use it to determine bots, right? So some bots that are coming to your sites are good bots, they're coming from partner sites. So you want to allow access to your website to those good bots, while they want to block the bad bots that are coming to your site. So they can actually detect in real time which are the good bots, which are the bad bots, and prevent the bad bots from accessing your site, while allowing the good bots to access your site. So the reason they picked NewSQL was because they really needed extremely low latency. They needed under 50 milliseconds of response time, and they needed extremely high throughput. So that's why they picked NewSQL. Then, anytime you have transactions that are financial, you need really, really strong consistency. And hence, again, these asset semantics is another reason why they picked NewSQL. And they had SQL DBAs at hand, and who were comfortable with, obviously, with relational databases and with SQL. So that was a factor in them picking NewSQL as well. And unlike NoSQL databases, you do not have to compromise on consistency for availability. NewSQL databases always guarantee high availability and scale and immediate consistency. So rather than NoSQL databases, which kind of, you never know what response you're going to get. And especially in financial applications, you have to ensure consistency at all times. And that was, again, a critical reason why they picked us. This example is from Emagine. Emagine is actually a platform in Asia that does customer value management. So basically, they sell their platform to telco companies. And in Asia, prepaid telephones are very popular. So a lot of the population there uses prepaid telephones to make phone calls and also to access the internet. So they also say prepaid promotions for data as well, in addition to voice. So that's what they say. So sell basically. And what happens is the research has shown that if their customer is using their data plan and or their voice plan and they ran out of minutes. Basically, if they make them an offer to extend their plan or the data or voice plan in milliseconds before they put the cell phone from their ear to the pocket, they actually have like a 40% or 50% better chance of them accepting and buying that offer. So that's what they used VoltDB for. Basically, they were able to analyze the customer's usage habits. They analyzed how much data they consume, how much voice how much of their voice plan they consume, and they were able to customize offers and make them in real time. So basically, once the customer hangs up and before he can even put the phone in his pocket, they were able to make a very, very customized offer to them, and based on the machine learning algorithms that were embedded in the database. And with that, they were able to ingest about 1.5 billion records a day for each subscriber. And their decisions were all under 3 milliseconds. So with that, they actually increased their conversion rates by 40% just because of the real-time offer capabilities that they added with the NewSQL platform that they had. So we've talked a lot about the use cases. Let me talk about something that's going on right now, actually. So with the advent of 5G, a lot of our telco customers are looking to employ NewSQL in 5G applications. Again, as I mentioned earlier, with the unprecedented scale of the volume, the variety, and the velocity of data are going to increase even more with 5G. So their latency requirements and their scale requirements are even more stringent now for 5G apps. So one of our customers recently ran a benchmarking study with VoltDB on a 5G app, and they had really extremely strict requirements. So here's some of the results for the benchmarking study that they ran. Basically, they ran their study on 16 core machines, and that is what they would use in production. So it's it simulates the production scenario very closely. They ran NewSQL basically on 16 core machines with 16 partitions, and you can see at a cluster size of 27 nodes, they were able to achieve over 3 million operations per second. And I think I believe their requirement was only about 1 million operations per second, so it well exceeded their requirements. And they were also looking for latency of under 5 milliseconds. And here's the latency results from that benchmarking study that we just did. And you can see that the latency was well under 3 milliseconds actually for each of the node counts. So we had cluster sizes of 3 nodes, 7 nodes, 9 nodes, 18 nodes, and 27 nodes, and the latency was well under 3 milliseconds for each. And the other thing they wanted to achieve, in addition to the latency requirements and the throughput requirements, was scale. And they were able to get linear scale and scale vertically by adding more nodes and to increase their throughput. So as you can see in the previous graph here, the scale was pretty linear, so they were very happy with the performance that they got and the linear scale they got. So because VoltDB is a distributed system, it's a distributed database, and it's cloud ready, this actually study was done on the Google Cloud Platform. So this worked really well for them, and they were able to get everything they achieved. So I think they're going to go ahead and deploy this in production relatively soon. So, but we urge you to, test it out for yourself. We will make available to you all the data that was actually used in this benchmarking study. We'll also provide you the app that we used. Check it out yourself. So you can download the data and the app, and run it and see the scale that you can get, and the throughput that you can get, and the performance that you can get for yourself. VoltDB is open source, so you can download it and use it. You don't have to pay a dime, and you don't have to run the complex telecom app to get started either. You can get started with a simple benchmark app that we have. We'll make all these available to you. But essentially, the best, if you really need scale, limitless scale, linear scale, you need very high throughput, and you need really, really low latency, along with all the benefits of SQL. If you know SQL, or if you would like to learn SQL, then NewSQL is the right technology for you. And, if you look at this chart here, you really, traditionally, you have to compromise on availability for consistency, but you get the best of both worlds with NewSQL. You really don't have to compromise on availability. You get the high availability, you get the consistency, you get built-in machine learning, and you get the really high throughput and low latency as well. So feel free to check us out. And we also have an example that we put in there that you can run, which is a fraud detection example with actually machine learning built in. So we already have an algorithm built in. So you can take us for a test drive and check it out yourself. I think that's about all I had. So we'll go to the Q&A session.
Great. Thank you so much, Chai. We do have a couple questions that have came in. Our first question is, can VoltDB run analytical queries?
Yes, actually. So as I mentioned, VoltDB is what they call HTAP. It's a hybrid transactional analytical processing operational database. So you can actually run analytical queries in addition to your traditional OLTP. You can do OLAP queries as well. Good question, though.
Great. Our next question is VoltDB available on AWS?
Yes, VoltDB is available on Amazon Web Services. We have we are in the marketplace, the AWS marketplace, so you can download us there and you can use us. So yeah, and you can also, if you're on the Google Cloud or on Azure, we have a we have a container Docker image that you can use to deploy in those clouds as well. So we're cloud agnostic. You could pretty much deploy us on any public cloud or even a private cloud for that matter.
Great. Our next question is VoltDB certified on OpenShift?
That let me pass it on to my colleague.
Yeah, so thank you. That's a good question. So Red Hat has the OpenShift platform. We know of customers that do use us in that capacity. However, we haven't officially passed the certification for that yet. We also have a Kubernetes-based implementation that we launched that is available for you guys to use to deploy us at scale. Right? It allows you to spin up a VoltDB cluster using Kubernetes and also manage it over time. Thank you.
Thanks to my colleague Madhuk there for answering that question. Thanks, Billy.
Thank you. Other questions? Our next question is, can I orchestrate VoltDB using Kubernetes?
Yes, you absolutely can. VoltDB can be orchestrated. traditionally, VoltDB being a stateful database and Kubernetes being designed for on web apps, which are kind of dynamic. It was a tough problem to solve, but yes, now VoltDB can be actually orchestrated with Kubernetes here.
Awesome. Our next question is, how does this scale horizontally and across data centers?
You mean, yeah, so VoltDB does partitioning. So basically what it lets you do, as I showed in that a benchmarking example we did, is that you can actually you can use multiple CPUs within a server or across servers to kind of take advantage of our partitioning. So basically, commands are queued by partition, and they're executed by each CPU across partition. So each command is executed individually in each partition, and each partition maintains strong asset semantics. And we can replicate not just across servers, but also across different clusters and different geographies as well. So we have active disaster recovery that goes across different regions even. And so if you have a data center in Europe, you can actually have replicas in Europe along with your data center in the US. So if the US data center goes down, you keep running in production because you have a replica on your data center in Europe.
Wonderful. Our next question is there any administrative tools to manage VoltDB?
Yeah, so my colleague Madhu will answer that one.
Yeah, there's lots of tools. We encourage you to Google us, go to VoltDB University, and VoltDB, all the documentation is online. So feel free to check us out. We do provide a VoltDB management console that for those of you who are not CLI people, to take a look at the feeds and speeds and how the clusters are doing and what the configuration is. We can also be run through our SQL command operator, so you can manage us via CLI as well.
Great. Looks like we have one more question. So audience, if you have any more questions, please post them into the questions panel. The last question that we currently have is, how straightforward is a data migration from other databases?
Excellent question, right? And I've yet to meet a database company that has a smooth answer to that question, right? So ultimately, it comes down to how well you understand your application and what it's written in. There are certainly tools available for you to move things over to VoltDB, considering we're SQL based. However, because we are NewSQL and we have a partitioned core-based architecture, there are nuances on how your application will get sharded, across lots of different servers. So long as you understand what you're doing, it's something that you can get done fairly easily. We also have services and support that we offer, helping customers who need some help and hand-holding along the way.
Great. We did have another question come in. The question is, how do you compare VoltDB to timescale DB?
So timescale DB is one of many time series database options that are fairly popular these days. Time series is a subcategory of NoSQL, which is what Jaibat covered earlier on. You can manage time series within VoltDB because VoltDB does support time series capability. However, we're not simply a time series based database like timescale DB.
Great. That looks like all the questions we currently have. Is there anything you would like to add, Chai, before I close things out?
Yeah, thanks for everyone for joining and for your time. I appreciate it. Thank you, Billy.
Great. Well, I would like to thank you, Shai, for a great presentation today. I would also like to thank today's sponsor, VoltDB, for providing the audience with a great webinar presentation. And lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Have a great day, and we will see you next time.